Cycles have gotten very complicated in many ways based on external events such as torque events, altitude, landings, starts, or just a few factors. CompuTrack has the ability to solve this issue with calculated cycles. In this example, we will create a Trennian wren which multiplies torque events by 2. This figure is held in K1, which may vary. In the beginning, we need to set up a calculated cycle after you select the aircraft. Expand more tasks. Click Cycles Master. We're going to use Trennian wrens. Now, if you don't see Trennian wrens in this list, then you'll click it, select it from the existing cycles, and if it's not in this list, you can add it new. But we're going to use Trennian wrens, so we click it, and it shows we'll expand calculated cycle, and we want to add a new step. What we're going to do is select torque events, multiply K1, and K1 will set it as 2, and that will be on the individual component. Now you see the equation is all set up for the calculated cycle. The next part, go to Components, and we have the Trennian here. We will add a new limit, and that limit is going to be 24,000, and the description is going to be Trennian wrens. Frequency is going to be a cycle, and type this as a retire. Okay, install that aircraft. Total time is going to be 21,176. Prior to install is 15,266, and the alert factor will set at 250, and accept. Now you can see the finished product. It shows the Trennian wrens cycle, and it shows a current of 15,730 with an 8270 remaining. This is correct based on prior install and when it was installed on the aircraft. Another example would be penalty factors. So when we fly above certain altitudes. So in the case of the right servo bracket, 1 hour of flight time actually applies 9.7 hours against the component life. On Cycles Master, expand more tasks and open Cycles Master. What we're going to use is the hours swash plate for the calculated cycle. So we'll select that. If it's not in this list, then select it from the existing cycles list, or you can add it. Now we'll click Calculated Cycle, add a new step. What we're going to do is take hours, and we're going to multiply that times K1. Now in the component, we'll set K1 at 9.7, so it'll multiply whatever the hours are on the aircraft times 9.7. Okay, we have that set up. Next step would be to set up the component and add the calculated cycle to the part. So we'll open Components. Notice we have this right-hand servo bracket. It shows the hours. So we'll expand Limits, and we're going to add a limit, and it is going to be 40,000 hours. The description, it's going to be our hours swash plate, and here. And frequency, it's a cycle. You'd think it was an hour, but it's not. This is a cycle. And the type is, it is retire. All right. Now then, it shows the install that aircraft time. Well, we're going to just set that at 0 because this is already on the aircraft. All right, we accept here. All right, now then we have the swash plate hours. Component settings, we have K1 set at 9.7. So you see, if you take 126.1 and multiply that times 9.7, you'll get 1223.1. And that's how we do a calculated cycle for a right-hand servo bracket.